Hello and welcome. How are you, Kabir?
Doing great. How are you, Ed?
I'm very well, thank you, and thanks to everyone who's joined us. So, yeah, I guess we'll get cracking straight away. So, I have the pleasure of being joined by Kabir Peshawaria, who is a cryptographic software engineer who's currently working at Olvatana. So, I will get Kabir to give a full intro on himself in just a moment. But to start with, I always thank Kabir, and I was lucky enough to meet him in person in London a couple of weeks, or probably a couple of months ago now, at ZK10 back in September, I think, wasn't it?
Yeah, yeah.
So I have Kabir to thank for. So Kabir started me on my entire ZKP journey, sort of probably about 4 months ago now. So I have Kabir to thank for. So to give you some background, I'm a recruitment consultant at Understanding Recruitment, based here in the UK, and I moved from our JavaScript team to our Rust team, and I was dumped into the world of Rust and didn't know an awful lot about it. So I dived straight in, and we were passed a role which was in the ZKP world, which I just thought was almost like any other Rust engineering position. But little did I know that this small little niche that is called zero knowledge proofs is well, exactly that, a real niche, and a little bit far removed from a typical software engineering role. So Kabir was the first ever candidate and engineer I spoke to who did anything to do with zero knowledge proofs, and he helped my understanding and helped me along the way. And although I didn't manage to place him, he's been a great help for me and started me on that journey. So I'm thankful to him, and it's great to have him on today. So that's a little bit about me, very briefly. Do you want to introduce yourself quickly, Kabir?
Absolutely. Yeah. And little did you know that you were really lucky to get to work in zero knowledge proofs.
I know.
Yeah. So a little bit about myself. I graduated back in 2020 from Carnegie Mellon. I studied computer science and math. Specifically, I was really interested in theoretical computer science. Since then, I've sort of been bouncing around companies. I've worked at a couple of startups. Most recently, I worked at two zero knowledge proof startups. One was called Proven, and I was there for a year. I was the first engineer there and the first employee there. And at Proven, we worked on developing secure financial solutions using ZKPs and other cryptographic tech. And that's probably the experience that I think is most unique and that I'll probably be talking about the most today. More recently, as I was leaving Proven, I met Ed and a couple other great recruiters. And as Ed mentioned, I didn't get placed through him, but he did make very high quality connections for me, for which I'm very grateful. And yeah, of course, I'm very happy to be here today to talk to him. And now I work at Olvatana as a cryptographic software engineer. And just very shortly, Olvatana is a company that does hardware acceleration for zero knowledge proofs. And we'll dive into what all of those weird words mean, I'm sure, later today.
Perfect. So thanks for that quick rundown. And yeah, we're going to touch on loads of bits and pieces. So I'm sure we'll cover all sorts, but including your journey, a little bit more around the technical side of things as well. But anyone who's logged in and listening, if you've got any questions you would like, I was going to say you want us to answer, but more than likely want Kabir to answer. And for anything recruitment related, hopefully I can help out as well. But any questions, just fire them in the comments, and we'll be able to help out. But I guess to start with, I'm assuming we'll have hopefully people of varying levels of understanding joining us, whether they are, have no idea about zero knowledge whatsoever, whether there's people who, maybe software engineers who want to get involved, or there might be people who are currently working in the zero knowledge space. But to kick us off then, what on earth is a zero knowledge proof?
The hardest question first. Well, okay, so I'm going to first just say a little bit of a thing. Whenever you hear about these things for the first time, there's a lot of excitement. You're like, wow, that is the coolest thing ever. That seems like it just solves everything. But at the end of the day, it's just another tool. It's a really cool tool. It's a very cool primitive, but it can't do everything. But for now, I will tell a little bit of a white lie. And a zero knowledge proof basically is a interactive protocol between a prover and a verifier, where a prover wants to convince the verifier of some statement, and they're able to do so without revealing any information other than what you can glean from knowing that the statement is true, right? So anything that you can sort of mental model in your head along the lines of, I want to show someone X, but I don't know how to do so without also having to reveal why, that is a perfect paradigm for where one can apply a zero-knowledge proof.
Awesome. And I mean, I guess on the face of it, and once again, we'll touch upon it a little more, obviously incredibly powerful in sort of security and privacy, but there are a large factor around zero-knowledge proofs is all around a scalability factor as well, and how that can be a useful tool for scaling Ethereum, for example. So once again, I'm sure we'll touch upon that in more detail. But you've obviously got some experience in the Web3 space and the blockchain domain right now, and obviously in the financial sector as well. And but I guess there are quite broad and varied use cases at the moment, which is, it's such a niche right now. There are so many, studies going on. There's so many white papers and investigations into different use cases. But where are we at now? Obviously, a lot of it is in the Web3 and blockchain space, but obviously it's going to broaden. But why are there so many use cases, and what are the potentials moving forward?
Yeah. So ZKPs have been around since about the 80s, but they've only recently really grown in traction. Probably a couple of reasons for this. One is just some really great breakthroughs in cool proof systems. I'm sure many of you may have heard of Groth16, which was a really cool step forward in what's possible with proof systems. But another reason is obviously just a lot of money poured into cryptography research in general, thanks to Bitcoin and other blockchain development. And so where we're at right now is that most of the applications that we see for zero-knowledge proofs are being used in Web3 or in blockchain, and there are good reasons for this, which I'll touch on in just a second. But to circle back to something that Ed said before, when we talk about zero-knowledge proofs, it's sort of an umbrella term. It's a nice marketing word, right? And zero is a cool word, when you have zero sugar, 0 calories. It's a nice way to reel people in and draw their attention. But sometimes people don't really use zero-knowledge proofs for the privacy aspect of it, as Ed mentioned. Sometimes it's for the scalability aspect. So you hear about these things called ZK snarks a lot. And this snark object itself doesn't need to be zero-knowledge or privacy preserving at all. It's just a succinct, short proof of some arbitrarily complex computation that can be verified really easily. And one reason you might use this, and what is being used most today, is to scale layer 1 blockchain solutions like Ethereum or Bitcoin. Ethereum and Bitcoin both suffer from this problem where they don't have much throughput. The number of transactions you can do per second is not nearly enough for what we want. They have other great properties, like this is controversial, nicely decentralized, and they're very secure, but you'd like to be able to do more than, let's say, 10 transactions per second on the Ethereum network. So what you can do instead is you can take like a batch of transactions and you can create a short proof that, hey, all these transactions are valid, and you can sort of put that batch in as a single native transaction on the Ethereum blockchain. And everybody who's looking at this and trying to decide what the new state of the blockchain is will say, okay, these 1,000 transactions happened. And we'll just pretend like they were all part of the normal consensus mechanism. So that's mostly what ZKPs are used for today. It's usually used for their succinctness property, not their privacy property. Of course, there are like several applications that use them for their privacy property. Zcash, for instance, Alio, there's many of these projects out there. Sort of name dropping for those who may be familiar, but if you're not familiar, just know that in your mind. But what I will say is that at Proven, something that we were looking to do is to try and bring ZKPs sort of outside of blockchain use cases only. And I do think that there's a lot of potential for us to be able to use ZKPs for things that are not crypto native. But there are blockers to that, and that's something that I would like to elaborate on a little bit. You tell me when the right time is, Ed.
Well, you crack on now. I mean, from my understanding, some of the conversations I've had, some of the blockers around, the availability of hardware, for example. Obviously, you're touching upon hardware acceleration at Albertana, so maybe that will lead in nicely as well. But I think that's some of the challenges to to why it hasn't maybe accelerated into the Web 2 space potentially as quickly as we'd hoped? Or I
Sure.
appreciate we're still in
I
our
guess I
infancy
will
with zero
touch on it
knowledge.
now, since I don't want to be too mysterious, I guess. At least I'll give at least half an answer right now. There are a couple of reasons why it's easier to use ZKPs in like blockchain world or Web3 world rather than in real life. And the main reason I would say is that you have this sort of oracle problem, right? Zero knowledge proofs are great. I can prove something to you. But if the inputs to a proof are garbage, then the whole proof is garbage, right? And when you do things on chain, you have all of the sources of truth right there. It might be encrypted, but there's still this immutable, agreed upon state that everybody can point to and say, this is real. If I'm trying to do a zero knowledge proof, in the real world, and I'm trying to prove to you that my bank balance is at least $100, you have to trust somebody. You're going to have to trust that the bank is not lying to you. And then all these questions of how do I verify that the inputs provided are actually correct to the zero knowledge proof that's a tough question. But it's not intractable. It is possible to sort of still develop protocols around it.
And do you think that's near? I mean, that example, for example, is a perfect one. It might be, you're doing a mortgage application, like you said, and you want to prove, everyone's done a mortgage application where you have to provide an unholy amount of paperwork to prove that you can afford this property, for example. Whereas the zero knowledge proof could nice and easily say, yep, I can prove that I've got X amount without needing to know every transaction over the last 3 years or whatever it is. Is that close, do you think? Or like you mentioned, potentially some stumbling blocks to get there?
Yeah, that's definitely something that we could do. And there are roadblocks, but I don't think that they're insurmountable. I think that, so I'll touch on this a little bit. One way that you could sort of get around this problem is if you have some sort of truth that people have to commit to before they know what's actually going to be beneficial for them, then you can develop really interesting protocols here. For instance, right, like when you're a small business and you're filling out your taxes for the year, you have to write down exactly what your expenses were, right? Maybe I spent $700 on cleaning, $1,500 on salary, whatever. At the end of the day, the government really cares about just your total expenses, and that's how they determine what your profit was and how much it tax you. Fine. So why am I itemizing everything? Well, because today I don't know what policies are going to be implemented 2 years from now, right? Maybe 2 years from now, the government will come up with something that's like, hey, if you spent a lot of money on cleaning, we appreciate that, so we're going to give you a rebate.
Yeah.
In a similar vein, you can create protocols where you think about the incentives, where people have to commit to things ahead of time, not knowing what's going to be beneficial to them in the future. And then they sort of have to tie all of their zero knowledge proofs the same commitment.
Yeah.
Right. Your mortgage has to go through the same commitment, and maybe like a loan you take from the bank has to go to the same commitment. Maybe it would be beneficial to tweak your numbers in one way for the mortgage and another way for the other application, but you don't get to do that. And so that's sort of a way around this problem of not having a good oracle for a source of truth. That makes sense.
Awesome. So yeah, I mean, you touched upon it a little bit in terms of your journey with Proven and how you started in the space. So I believe I'm right in saying that when we spoke a little, probably 4 months ago for the first time, you almost stumbled upon the world of zero knowledge proof. Am I right in saying that you joined Proven thinking you were doing one thing, they completely pivoted, and there you were, suddenly you found yourself doing all these cryptographic primitives, etc., etc. So yeah, how did you get into the space?
Yeah, so the three founders at Proven are all great people. They're all really, really smart. Their main background is in finance. Two of them were Jane Street traders, and the other one was a portfolio manager. And when I joined Proven, there were kind of a few ideas that were being floated. I sort of immediately started on this project independently, which was like assigned to me. It's not that I just came up with it, which was to create a zero knowledge proof of solvency for crypto exchanges and the like. And our other founders were working on other projects. But obviously when FTX collapsed, this became a higher priority project.
Yeah.
So we had more hands on deck. I had a coworker, Massey, who was excellent and really helped push that project along to the finish line. But yeah, when I joined Proven, I wasn't exactly certain what I was going to do. And for what it's worth, I think that if you join a startup that was as small as Proven, it basically had nothing at the time that I joined. It was just 3 guys and some ideas. When you join a company that's that small, you shouldn't be joining with the expectation that you're going to be working on a specific thing, because you're naturally going to pivot and react to market forces and stuff. What I was really excited about was I had the opportunity to learn from 3 people who were really smart, great mentors, and I'm very grateful for that time there. But yes, you're right. I did sort of stumble headfirst into cryptography. The things that we were going to build originally at Proven were a little bit more finance and cryptography, but then it became sort of more just cryptography as time went on, just because of FTX, and nobody could have predicted that. But yeah, maybe I should touch on exactly what it was that we did at Proven, this zero-knowledge proof of solvency solution.
Absolutely, far away.
Basically, if I am a crypto exchange and I want to prove to you that I'm honest, how would I do that? Well, one way is I could write down every single customer that I have and what I owe each and every single one of them. I owe this guy 7 Bitcoin, 3 Ethereum. Then I would also have to write down basically every single wallet that I own on the chain, on the blockchain, and say, look, I have 5 Bitcoin from this wallet, 3 Ethereum from that wallet. And then you would just add up all the numbers and you would be like, okay, my assets for each coin exceed my liabilities for each coin. Obviously, no exchange wants to do this. Obviously, no user of an exchange wants to see their exact balance posted on some bulletin board, right? So what our company was trying to do is we were trying to come up with a ZK solution to this, right? How can I create a protocol where the assets are hidden? I don't have to tell you exactly what I own. Liabilities are hidden. And this wasn't just a cryptography question. This was also a mechanism design question. This is an incentive question, right? How do I make sure that every user's balance is included when I'm summing up the liabilities? And that was just based on, incentivizing users to check and incentivizing exchanges to not cheat and try and leave out a user balance. I can elaborate on this more if people are interested, but essentially it was just this protocol that, computes the assets by taking in some snapshots of the current state of the blockchain, and then proving that you own a specific wallet in that blockchain, which is associated with a specific balance, adding up all my assets, and then doing the same on the liability side, giving users a way to check that their liabilities were included in the total computation, and then comparing at the top whether my assets were greater than my liabilities. There are other ZK proof of solvency solutions, but at the time of creating this, I wasn't really aware of any of them. Now there's Summa and some other really cool ones. I have not looked into exactly how they work, but I can vouch for Enrico from the Ethereum privacy scaling and exploration group. Stand-up guy. I'm sure that whatever he's doing is probably legit.
And to me, that seems like, from an outsider, that seems like one of the most obvious use cases of ZKP, to prove ultimately you have a sum to be able to make a transaction without needing to almost know anything else. And almost like we touched upon a little bit how that could be, moved into the Web 2 space as well. But you mentioned that was a bit of a unique role.
Yes.
But anything else you want to touch upon with that?
Sure. I mean, look, when I joined that, I am a math and CS guy, like I said, but I didn't know much about zero-knowledge proofs other than from like a very theoretical standpoint. Like I had no idea how they were used in practice. When I started this project, as I mentioned, it was just me. Other people were working on other projects. And I had no idea how to begin. I think that, the only reason I talk about that is because I just want to share with people that my advice for how you can actually just dive in and do something is to just stop thinking and try and do it. There's a lot of really great online resources out there for you to learn these things. I'll probably talk about them later. But yeah, I think that the most important thing that I learned from that whole experience is really abstraction, 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 right? One thing that happens when you're trying to approach such a complicated subject that you're not very familiar with is you feel kind of overwhelmed. You see all these experts who are talking about these things and you're like, wow, I'm never going to be able to do that. But what I've been very fortunate to have in my career so far is I've been able to see how a lot of really, really smart people think and how they approach problems. And what I could share from that for people who may have not had those opportunities is that really smart people don't think about everything from like how the atoms are interacting all the way up to this very high level complicated mathematical construct like ZKPs. They black box a lot of things and they rely on their intuition. And your intuition is something that can be trained and that can be built. And you just sort of have to trust that the layer beneath you works the way it's intended to.
Yeah, I mean, you touched upon it a little bit there, and I think you've got, from a recruiter's perspective, you've got quite a typical background, so to speak, for what a cryptography engineer looks like in terms of a comp sci and mathematical backgrounds from an awesome college. I know obviously you fell into the world of zero knowledge proofs, but yeah, what you touched on it a bit. What advice would you give for someone who's trying to enter the space? Because already I'm having these conversations of people who are maybe currently doing their master's or PhD, or people who are your more typical software engineers who'd love to get into the world of ZKP and maybe work as a cryptography engineer, for example. And so yeah, appreciate you maybe didn't necessarily do this, it sort of fell on your doorstep, but any advice you would give?
Yes, 100%. When you're trying to understand how a car works, right, you shouldn't be trying to start with understanding fluid dynamics and I don't know how the braking fluid works inside of a car, right? You should just think about very high level abstractions. Oh, the steering wheel does this, the engine does this, what each part of the car does and what it's supposed to do. And I think the same is true for things like ZKPs. I've seen friends trying to explore the subject and I've seen them go about it and what I consider to be wrong. They start really diving into the math behind it and the algebra. And I think that's absolutely the wrong approach, especially for people who are not formally trained, because it can be really daunting and it can feel sort of overwhelming. What I strongly suggest is that you think of an application or something that you're interested in doing, and then you try and learn what's necessary to do that. The other thing I'll say is that, keep plugging your curiosity. Like every time you're curious about anything, just Google it. Just Google it instantly. Because, the first 100 times you Google something, it's not going to make any sense whatsoever. But little do you know that in your subconscious, your brain is making all of these small connections and recognizing patterns. And eventually there'll be some emergent behavior. And I promise eventually there's going to be some aha moment. This is something that's very difficult, especially if you're not formally trained, but the tooling is getting better and better. You don't need to really understand exactly how a proof system works or how all the complex math works. Now you only need to understand how to write a circuit. I should probably touch on what a circuit is at some point, but what I'm trying to say is that it's important to abstract away as much as you can and to not try and dive into the crazy deep math. But nonetheless, don't be afraid of seeing those words over and over and over again. The more you see, the more exposure you get, the more you hear, you might not think you're understanding anything, but I promise it'll eventually all make sense. And anybody who is passionate about this stuff and cares, every single person is capable of learning this. And I truly believe that from the bottom of my heart.
And I've got a question that I'll hold fire just for now, because I think it'll lead on nicely if you describe a little bit more about what a cryptography engineer does. So like I said right at the start, it is a little bit far removed from just your typical software engineering role. There are far more complex aspects you've mentioned around circuit design. So what does and we've had a question as well asked in the chat, but yeah, aside from just your typical software engineer, what does a cryptography engineer do in the zero knowledge space?
Good question. So a cryptography software engineer is basically somebody who, maybe reads papers on zero knowledge proofs and turns that theory into practice. Their role is probably to provide, good library code that can help developers who are less familiar with cryptography be able to use the power of cryptography. If I'm, just a really good software engineer, but I don't know much about cryptography, I shouldn't have to be thinking about the innards of how all these ZK stuff works. The library should be really good, and it should abstract away all the complexities for me. So the role of a cryptographic software engineer is probably two things. One, good abstractions and simplifying things, and like providing good library code in general. And two, performance. Being able to write fast code, highly performant code, both in terms of efficiency time-wise, how long it takes to run the code, but also memory efficiency, how much space and memory does it take to run the code.
And I mentioned before, we obviously bumped into one another at ZK10 in London, and it was certainly a bit eye-opening for me sitting there in the talks. And I've said it to people before, I've been to sort of software meetups in the past, and obviously, 90% of it goes over my head, but some bits I can get my head around. But in the world of zero knowledge proof and cryptography, the sort of circuit design, the algorithm, the mathematical side of things was, something, beyond what I could ever get my head around. But I guess that's obviously why, a lot of cryptography engineers, or virtually all of them, come from that sort of mathematical side of things. So the question that I was holding fire on is, obviously you were, your typical software engineer, you got dumped into a world of zero knowledge proof. You suddenly have to deal with all these, all the algorithms, the circuit design, the mechanism side of things. How did you find that from, almost having, I'm assuming, little to no experience, to doing that virtually as your job? Because I guess from a hiring point of view, it's a bit of a battle for me, because people ultimately hiring a cryptography engineer want a cryptography engineer who's already doing it, who's already the total package. So my question to maybe hiring managers is, why can't we have a Kabir who's an awesome software engineer who come from that comp sci, that maths background, and just upskill them? So that's a very long-winded question, but basically, how did you find picking up the cryptographic side of things from sort of ground zero?
Yeah, I mean, your question actually is very valid and kind of unfortunate, right? It is difficult to, as a hiring manager, make that call to try and hire someone who's very interested and passionate to learn. Everybody wants someone who's already fully cooked and knows how the ropes work. I was very fortunate in that, I sort of had a gateway drug in Proven where I got to write really cool, large snark circuits. But I don't think everybody is going to be fortunate enough to get that experience. I don't really have advice for how those people can convince hiring managers that they should take a chance on them and upskill them. I think I'm probably too early in my career to have that sort of perspective on what it takes to convince a hiring manager to take a chance on you. But what I will say is that there is, if you're curious about this stuff, you can sort of just passively read about it on the side. You can go to hackathons, you can join these Discord groups, and you can meet people through that. And honestly, yeah, just networking that way. If you meet people at these ZK hack events, at these conferences, on Discord, in these study group chats, and you show that you're genuine about learning, I am certain that someone who has sway in the community will vouch for you. And I think that could go a long way.
Yeah, and I think that's a massive part of it as well, is obviously, I've had these conversations before, but just ultimately getting stuck in, as with anything really, but once again, the community that you mentioned is very tight knit. There's obviously not many startups in the zero knowledge space right away. Everyone seems to sort of know everyone, but there's certainly a community online or in person at plenty of different startup sort of conferences and hacks and events and stuff. So just immerse yourself in that community and immerse yourself into the technology as much as possible. I think would obviously is going to stand you in really good stead. So yeah, do you want to touch upon a little bit what you're working on now? So you've told us a little bit about your journey, about Proven, and then obviously about a year or so had come up in your time there, and you're now at Olvatana. How are things there? What you've been working on?
Yeah, so Olvatana has been great. As I was leaving Proven, my goal was to go even deeper on the stack. So at Olvatana, so far it hasn't been about writing circuits, but it's been about looking at proof systems in general and how to make them faster. Of course, I'm not here to plug Olvatana, but I will talk a little bit about what they've been doing just because. Recently, they came out with a new paper for a new snark proving system. And it's not me. It was all Jim and Ben and their genius that came up with some of these ideas. I should probably describe what a circuit is before I get into this, but I'll chug along anyways for those who are familiar. Their new proof system is meant to make circuit designers have more power to write more efficient circuits. And it's really cool because it makes proving times much faster for specific types of applications. And so far I've been working on the open source implementation of this proof system called Binius, which is written in Rust. And I'm actually quite new to Olvatana, so I don't know what's coming next. But what I do know is that everybody I've been fortunate to work with is really smart, really good at communicating and explaining tough technical concepts. And I've had a great time so far.
Awesome. And I mean, there's a couple of things to touch on. Do you want to, I don't know if you can do it in it very quickly. I know these topics are so complex, but you mentioned a little bit about sort of Rust-based proving systems and
Sure.
obviously how they're used to sort of, prove ultimately these circuits. Do you want to try, if you can, to dumb that down for people like me who maybe don't have a clue what we're talking about?
Sure. Let me talk about what a circuit is. Trigger warning, there's going to be a little bit of math. So when we talked about what a zero knowledge proof is, or let's just drop the zero knowledge, let's just talk about like these snarks. So a snark is a type of proof object. It's called a succinct, non-interactive argument of knowledge. So let's break that down. What does that mean? The succinct just means that the proof that you get is going to be very short. The non-interactive means that, we don't have to do a bunch of back and forths for me to be able to convince you. I'm just able to send you a proof in one shot. Now let's talk about the last part, argument of knowledge, right? An argument just means like a computationally sound proof. It's not like 100% certain, but that's fine. We're fine with security that's close to 100% secure. Like you don't worry about the fact that I could theoretically guess your password if I got really, really lucky and press the right keys. And now this argument of knowledge, what does that mean? So when a prover is trying to convince a verifier of a statement X, right? We all know about functions as a mathematical concept, right? You put in an input and you get out a deterministic output. There's another mathematical concept called a relation, right? Where we basically have these pairs of things, X's and Y's. And we say that X and Y are related if X, Y is in the relation. So why am I bringing up all of this machinery? Well, basically, we can think about, for those who know like theory of computation, you know exactly what I'm trying to skirt around right now. But you can think about this sort of correspondence between X being a fact and XY being in the relation, right? We can say that like X is a fact if and only if there exists a Y that is related to X. Okay. So now what snarks are and what these circuits are is they take in a fixed public input X, and what the prover is trying to show you is that they know a Y such that XY is in the relation. is related, right? This is stronger than saying that X is a fact. It's X is a fact, and I know that X is a fact because Y, right? So it's an argument of knowledge. It's not just an argument that something is true, but it's an argument that, hey, I know why it's true. Why is it true? Because of Y, right? So now what a circuit is like any of these computable relations, any of these functions, these relations, they can be sort of abstracted into a circuit, an arithmetic circuit, which basically means that you have a bunch of wires, and these wires go into these gates, and these gates can be multiplication gates or addition gates. If you've taken a bunch of wires into a multiplication gate, you get out one output, which is the multiplication of everything that came into the gate. And this sort of model of arithmetic circuits sort of fully generalizes computability. So now, as a circuit designer, I am trying to create a circuit, a publicly known circuit, so that a prover can fix a public input X that it's trying to prove to a verifier, and the prover can provide a secret witness Y to this circuit, and X and Y are all the initial wires to the circuit, such that the circuit doesn't, spit out an error at the end. That's a rough explanation, but
so you've got this super complex circuit that you've just described, and then which is sometimes difficult for me to get my head around. I totally get how you've got this. Well, I don't totally get it, but I get how you can build this circuit that you mentioned, and then somehow you've got to turn this into a bit of code, right? Is that where the Rust-based proving systems comes in?
So the proving system is sort of beneath this, right? The first step is to write a circuit, right? Writing the circuit is sort of what's typically referred to as the front end of a proof system. The back end of the proof system is where all the complex, gnarly math stuff happens. And for most people, you should not have to think about the back end of proving systems. You should just use an established one like Groth 16. You write your circuits typically in some domain-specific language, such as Circom or ArcWorks or Halo 2 or whatever. And it's sort of weird because what you're doing is you're sort of defining some instructions for how you can take some initial wires and you can do some computation on them with plus and times gates. But what you're also doing at the same time is you're also creating these things called constraints. The code sort of, couples these two to make sure that you're not making a mistake. But what's really happening on a mathematical level is that a circuit is really just, a circuit is really just a bunch of constraints, right? If I take this variable times this variable, I should get this variable. Is basically equivalent to when I'm doing some computation, this variable comes in, this variable comes in, goes into a times gate, gets out a new variable. What's really happening at a mathematical level is you just have this unordered list of constraints that all these variables must have with one another. And then what a prover does is they demonstrate knowledge of an assignment to all of the variables such that all of the constraints are true. Typically, when you use real-world libraries, it's very easy to have a mismatch between the constraints of the circuit and the witness that's generated by the prover. So we sort of force these two independent concepts to be coupled with one another so that it's harder to write bugs as a circuit designer. But they're actually different things. I apologize if that's not a great explanation. This stuff is sort of complicated, and I don't want to say wrong things to oversimplify.
No, don't be daft. I know it's difficult when something is so complex to try and bring it back down to earth, but no, you've done a great job. And I guess we'll touch on it very briefly, and I'm sure I'm going to know the answer to this, but obviously as a big advocate of Rust, being on the Rust team here, why is Rust so prevalent, if you like, within the world of cryptography?
I don't know. Maybe it's just some mass hallucination. Everybody is just, it's like a cult, honestly. No, I'm joking, but I do get it. I really do get it. Rust is a really cool language for a lot of reasons. And it's more than just, it was really hard for me to learn, so now I better like it. Rust has a very high, like, learning curve at first, steep learning curve. But once you get it, it's really rewarding. And the reason why I think Rust is particularly amenable for cryptography is that Rust sort of brings you all of the annoyingness up front as much as possible. Like, that's its ethos, that it wants all of the bugs that you can have at compile time. This is not true, obviously. Just because you write some Rust code does not mean that it's correct if it compiles. But often that is the case, and that's kind of beautiful and really nice. I'd rather waste my time coding than wasting my time debugging, because debugging is a nightmare. And Rust has great memory safety. With the borrow checker, it's difficult to write memory leaks unless you're writing unsafe code. They have great support for concurrency. The error messages are really nice. The type system is beautiful with like small features like fat enums. You can do like really cool things to make sure that the types that you're getting are always the type that you expect. And if not, you can panic and error in the right place or handle errors appropriately. Now, there's a lot of great reasons why Rust is useful language. It's sort of like a modern C++, many people describe it. Highly performant. Once you write things, you're pretty comfortable with its correctness as much as possible, in my opinion. But what I will say is, look, I'm not a Rust absolutist. You can absolutely write high quality performant code in Go, let's say. There's ZK libraries in Go, like by consist. There's Narc, I don't know how to pronounce it, gnarc. Yeah. Rust is a great choice, but it's definitely not the only choice.
That's well, that's interesting to know. But yeah, a lot of those things you mentioned there are some of the things that we hear, day in, day out about why, any company ultimately would opt for Rust. But when it lends itself so nicely to privacy, security, speed, memory safety, etc.,
with cryptography, you really don't want bugs. You really don't want to bug.
Exactly. Yeah.
The bugs are also can be very annoying because they can be very subtle. Because you're not really dealing with, these objects that really make sense. They're encrypted, weird nonsense. You really don't want to bug.
Awesome. I mean, we've touched upon loads of stuff there. If there are any final questions, then pop them in the chat. We've got a couple already, but one thing before we leave, what you mentioned about some of the advice that you'd give to people trying to get into the space. Are there any particular resources that you love? Is there any particular place that you go to upskill? How would you recommend anyone of, I guess, any ability, like I said before, maybe people wanting to get into the space or progress within the space, where should they look? Where should they go?
I'm glad you asked me, because I had to start this from fresh not too long ago, so I still remember everything that I used. The first resource that I think everybody should check out is there's an article on Medium by Vitalik. It's a 3-part article called Snarks Under the Hood. Regardless of your mathematical maturity, I think that this is digestible. And I really recommend that people who don't know anything about how this works start there. It describes Pinocchio, the proving system that's a predecessor to Groth 16. And in my opinion, it makes it as intuitive as possible while not removing the complexity. So Snarks Under the Hood by Vitalik, great starting point. When you're trying to learn how to program circuits, write circuits, there's a lot of great online resources. Pratyush, the author of ArcWorks and who's now a professor at Penn, has a great online resource about that called Programming with R1CS. R1CS is sort of like this language that you use to write circuits. It's one of them. There's others like Plonk that you may have heard of. It's mathematization language. But yeah, Pratyush has a lecture online about programming with R1CS. That's a great resource. Obviously join the ZK Hack Discord. I've never been a Discord person. I don't really live online. I'm what people call a no-coiner, which is embarrassing to admit maybe here. But I've recently come to appreciate how great the online community can be for helping for these sorts of things. There's study groups in the ZK Hack Discord that you should absolutely join. There's new people joining all the time, so don't feel like you'd be behind. Then if you're sort of already mathematically mature with this stuff, I would recommend Justin Taylor's book. He has a book called Proofs and Succinct Arguments or something. That's heavy stuff. I would not recommend that unless you're like me and you care a lot about the how and not just the why, and you really want to know how these things actually work. Justin Taylor has a bunch of great lectures on this, and he also has that amazing book. Finally, there's a resource called zk-learning.org. This is a MOOC, which stands for Massive Online Open Course or something, put together by Professor Dan Bonet and a lot of his professor friends. And this is also a really great resource, but maybe overkill for someone who's just trying to write ZK applications. And there's absolutely no shame in just stopping at understanding how circuits work. Not everybody should know how everything works all the time. If so, then experts have really failed the community. We should really be able to abstract things away and make anything, no matter how complicated, understandable and digestible. So if you are someone who really wants to know how the cookie is made from scratch, then zk-learning.org, zk-learning.org, Justin Taylor's book. If you're not, Vitalik's Medium articles are excellent. What else did I say? Yeah, the Discord chats are excellent. ArcWorks and other projects have really great tutorials on how you can get started with R1CS programming. There's also Noir now, the Aztec folk. They have also really good learning resource tools as well. But yeah, I think, look, if you get stuck, Discord, just ask on Discord.
Yeah.
This community is really, really helpful. And my biggest regret, honestly, is I think I sort of wasted a lot of time reinventing the wheel when I was starting at Proven because I didn't join the community.
Yeah, and that's something we've touched on a couple of times, but it is, the community aspect is massive. And I think it does seem, you can understand why it is almost daunting to outsiders, should we call them, to, looking to get into the space because they see the complexities of the work. But if you are that way inclined, there are plenty of resources. The community is awesome, that people just want to, share what they're doing and ultimately help. So we'll make a nice little list of those resources, and we can share those as well. So we've got one question here from Marlon, nice and simple one. You might be able to share a couple. What is your favorite ZK application? Do you have one?
Oh, like I said, I'm a no-coiner, so I don't really interact with blockchain or Web3 very much. But favorite ZK application, if you mean deployed application, I don't have a great answer. If you mean what I think it can be used for in general, potential use case, I think ZKML is cool. One thing that has happened for a lot of people is you're paying for ChatGPT, and one day you're like, oh, the quality of these responses are great. This is an amazing tool. And the next day you're using ChatGPT and you're like, okay, now it sounds like a third grader. What happened here, right? When I put in my query to ChatGPT, there's no reason why OpenAI actually has to give me a response from the expensive model that I paid for. Yeah. ZKPs, you can make sure that, or just proofs in general, not ZKPs, you can make sure that they're staying honest. I do have an actual favorite application. This is not amazing for humanity, but something that I think is cool nonetheless. Look, I have no idea who these guys are. I am not vouching for their integrity. I don't know anything about them, so please, big disclaimer. But there's a group of people who I think their name is PokerDAO.xyz, and what they're doing is they're trying to implement trustless poker. There was a paper a while ago by Adi Shamir, who's a big name in cryptography, called Mental Poker. And okay, so here's the scenario. How many of you have been playing online poker at some point, maybe with money or not with money, and you flop quad queens and you're like, wow, I'm just gonna go all in because I have the nuts. And then the turn card and the river card comes, and what do you know? The person who pushed all in with you with nothing suddenly has a royal flush.
Yeah.
Was this a fair system? Was this happening honestly? I've talked to many people who put thousands of dollars into online poker.
Yeah.
I don't recommend doing that. But they all say the same thing to me, which I think is sort of like misguided. They say that, look, if someone's cheating in online poker, if the system is a really trusted system, if it's like, giving one player a slight advantage or, messing with the cards a little bit to make me lose, then it's really obvious and I'll be able to detect it. And that's just not true.
Yeah.
Like computationally, it's probably it's probably very possible for a smart bad actor to mess with the cards and mess with things in a way where you wouldn't understand. But with trustless poker, which uses, amongst many other primitives, ZKPs, we can actually all play poker in a fair way just by talking to each other, assuming we had superhuman intelligence and computational power, which we don't. But theoretically, me and you could play a fair game of poker right now just by talking without cards.
Funnily enough, both of those use cases you've mentioned, I've had discussions with recently. Definitely the online gaming, the online gambling space. Like you say, you've got to potentially question the integrity slightly. Who knows what's going on?
The
But
incentives
also,
are not there.
yeah, exactly. And ZKML, yeah, how those two technologies can combine. Obviously, we don't need to go into detail about the
Obviously,
power of machine learning, but how
privacy as
those two
well,
combine.
like identity as well is a big one.
Yeah.
Privacy, there's a guy named Lowry who I think is working on a side project, which was like ZK proofs that you're over 18 for websites. I don't know, over 21 to buy alcohol, whatever. Those are cool ideas. One thing that I think I didn't touch on in the session that I want to quickly say is that ZKPs are awesome. Why aren't they used everywhere? One of the reasons was obviously the Oracle problem, but there was another problem that I didn't talk about, which is that on average, for most applications, ZeroKnowledge, like trying to do a ZeroKnowledge proof of a computation, is very, very resource intensive. It takes a lot of memory and a lot of compute power, and it also takes a lot of time. Like if I want to just hash like 10 kilobytes of data, let's say, it'll take me a few milliseconds, if that, just on my MacBook. But if I wanted to prove like a hash output, that might take me like a couple minutes. And so there's a lot of research and development, which I'm personally very interested in, to make snarks and like these proving systems faster in general and more scalable. And there's been a lot of really, really cool work in the space, which I won't even dare try and start to summarize. But when that matures, maybe it won't. Maybe we've reached like a theoretical threshold. I don't believe so. But when that gets better and faster, I think we'll start to see more applications of ZK. Or I'm doing the thing too. I'm using ZK instead of, but we'll start to see more applications of proof systems and snarks in the real world.
Yeah, and 100%. I'm already having conversations with founders of companies who are exactly that. They mentioned almost the inefficiencies of it, but also, some of these complex circuits or proving systems that we've touched upon takes a lot of man hours, don't they? This is a cryptography engineer's job for months and months on end. So ways in which they can ultimately like plug and play or just make this whole proving system more efficient. Like you said, watch this space. I think there's plenty of things coming which will, like you said, hopefully aid the growth of the space as well. Awesome. Well, I think that just about covers everything that we wanted to cover, unless there's anything else. But it's been an absolute pleasure to have a chat, and I really appreciate your time. Any final thoughts before we leave?
Nothing. If you listened this far, thank you guys. And I hope to see you guys at maybe one of the next conferences or something, and definitely say hi.
Awesome. Yeah, I really appreciate your time, and this will be made available on YouTube, and we'll share the resources that you mentioned, and I'm sure Kabir will be available to help out. But yeah, me and him I'm sure will be around at different conferences, so come and say hello. And yeah, I really appreciate your time. Cheers, Kabir.
Cheers, Ed. Take care.
Cheers. Bye.